Okay, today we are reviewing for the polar test. But it's not really just the polar test. It's a lot about how polar graphing compares to, what's the old style called? Rectangular. Okay. So the first thing I taught you was where a polar point would be, and then the opposite of where a polar point would be. So here's a polar point. Just graph this one for me. 5 comma pi over 6. So you'd go, I like to think of it as the angle first, but some people like to think of it as the length first. Okay, I like to know where I'm going before I start walking, and then you can tell me how many miles to walk in that direction. Okay, so I like to think, okay, so here's the line for the angle, pi over 6, I got to head in that direction. Now you got to tell me how far to walk. I'm going to walk 5 units in that direction. There, boom, that's the point. Raise your hand if you had that one right. Okay, good. Now, what would it have meant if I'd have said, I wanted you to find the point negative 5 pi, negative 5 comma pi over 6. That is in a different place. And this is weird, but you can't graph that because there's no negative lines on polar graph paper. So it's a place, but I wouldn't call it negative 5 comma pi over 6. I hope you know it's down here. And what would its name be on the polar graph paper? 5 comma pi over 6? No, that's over here. That's 5. By changing that to negative, it bopped it over here. And now, what's its name over there? It's got to have a positive 5. Otherwise, you can't graph it. Positive 5, comma. A lot of different ways you could say this now. This way, 7 pi over 6. What's another way you could have said it? 5 comma negative 5 pi over 6. Does that make sense? Okay, and then you can get rectangular coordinates for those points, etc. I'm not going to try to review everything for you because we've already been doing this. I want to give you a little practice quiz on this stuff and give you a chance to work on it for a while. I know some of you are going to have a few that you struggle with, and that's good because that means you're going to learn something, and we still have time to learn before we test on it. So I need you to have a partner. We're going to have these 2 rows slide together, these 2 rows slide together, these 2 rows slide together, and I'm going to give you 5 questions that I think are representative of this unit stuff we've taught you how to do. Am I promising that this is the only stuff that we would test you on? Of course not. But these are 5 types of things that I've taught you how to do. Now, this number 3 is the messiest one. I want you to look that over for a second. That is translate to polar and solve for r. So not only you got to get the x's and y's out of this and to replace them with r's and thetas, you also have to solve it for r. If you can't do the solve for r part, I wouldn't be too surprised, but I'm going to show you how to do that, and it's really not super hard at all. It's actually pretty easy if you know one little trick, which I think some of you will remember. All right, so some things you'll need to know on this, just like stuff you should have memorized. This is a test where a few things memorized would be really handy. What is x squared plus y squared equal to? All right. X can be written in polar as r cosine theta, and y can be written as r sine theta. Okay, good. Those are some of the main things you have to memorize, and there's a picture for that too. You don't have to have this picture memorized, but it would be handy because it could give you all those other equations. If this is r and this is x and this is y, you can see that x squared plus y squared would equal r squared. And you can hopefully solve for x after you wrote out cosine of theta equals x over r. You could get that solved for x. So All right. I am going to pause for a minute while I give you some time, a fair amount of time, to answer these questions, and then we will go through them one by one. I'll pause while you do this. Now, those of you listening at home to review for this test, if you just watch me do these problems and you don't stop right now and do them yourself, you will not remember. You will remember 10% of what I tell you. That's why I'm having everybody in class here write them. So if you're at home reviewing, do these problems, then unpause me and see me write them out for you. All right, I'm going to pause for now. Okay, we're up to most of the groups are now done. And if you're not done, guys, you feel free to continue working on that last couple problems. And on the very last one, I think I forgot to tell you that I don't need you to have like a gajillion points. Just have at minimum 3 points graphed. On the test, it'll tell you how many points to graph. But if you have at least 3 points, you're good. All right. So now, here's how you do the first one. I like to think of that point, negative 2 comma 5 pi over 4, as not really existing. Because it's a negative radius and you can't graph it on polar graph paper because there's only positive circles going out from the center. Okay, so if I were going to graph this spot, I would say it's at 5 pi over 4 first. I like to think of the angle first. Well, here's where 5 pi over 4 is. Okay, approximately. And it's off a little bit. It's bothering me. It's supposed to be 45-degree angle there. Good enough now. Now that's where 2 comma 5 pi over 4 is. That's not where negative 2 comma 5 pi over 4 is. That's where 2 comma 5 pi over 4 is. So if I'm supposed to get here, now I got to take this, and I'll do something I can probably only do electronically, but I'm going to transport this point over here. Now it's important to note that when you do that, you now have a point that will have a different angle. If I say it's positive 2, because its radius is 2, that's the r, and because I transported it to the other side, it now has a different angle. I now got to say it with that angle, which is 2 comma, what is that? Pi over 4. Or, another way you could say it is all the way around 2 there, which would be 2 comma, a whole bunch of pi over 4s, but negative 7 pi over 4. Either one of those would have been a good description of the polar name for that point. Another polar name for that point. There's only one I've left off even, which is this point with a negative angle. If I say this point with a negative angle, it would be negative 3 pi over 4. And then I could transport it over here and say, if I want to put it over here, I could list it as negative 2 comma negative 3 pi over 4. That's the last thing you could have possibly written. I didn't ask you to write all of them. I just write you to ask just to write one of them. So you could have written more if you wanted to. Just trying to show all the options. Last is rectangular. To get the rectangular coordinates, I like to actually draw the triangle out. And I showed you another way with r cosine theta, comma r sine theta. But honestly, we've drawn so many triangles in this class. And when I talk to the teachers of AP Calculus, whether you take it in the IB flavor or if you take it in just AP flavor, either way, they draw a lot of triangles. So I think it's just smart to draw the triangle for this and go, that's x, that's y, and I know the radius is 2. And if this is pi over 4, that means that that's a 45, and I'm going to draw the classic 1 root 2, 45, 45. I do that every time. I go back and draw the classic one in, and that helps me then look at these two and see what the ratios are. Then I like to go like this. X is to 1, like 2 is to root 2. Oops, 2 is to root 2. And look, I got x alone, 2 over root 2. And then, since this is the 45, 45, 90, aren't these supposed to be the same as each other? Yeah, they are. So both x and y are 2 over root 2. Raise your hand if you had that one right. All right, what would have made it more complicated? What if the triangle had been over here? Then the only thing that would have been different is I would have had to watch out for what's Negatives. Good. Both x and y would have been negative then. All right, let's move on. Oh, wait. How many had number 1 right? Okay, good. Now let's look at number 2 here, where we have 5 cosine theta is r, and I could square both sides because I have this saying in my head, x squared plus y squared equals r squared, but I don't have an r squared. But if you square both sides, you did it the long, painful way. What you should instead do is multiply both sides by r, because that way, that's an r squared, x squared plus y squared, and that's an x, 5x. There it is. Did it say you had to solve for anything? No. If it did say to solve for y, that's just algebra. You're supposed to know how to do that. Solve for y. If it said solve for x, that would have been particularly difficult. We'd have had to get them both onto the same side, and we had one kind of like that later in the test here, the little mini test. So, all right, moving on to number 3. Translate the polar. My first thought was to get the x squared and the y squared together. So I'm going to add y squared to both sides. And that way I have x squared plus y squared plus 4x plus 3 equals 3. Then I'm going to subtract 3 from both sides. Why did I do that? Because I wanted to get it to equal 0. And the 3's just both disappear. So there it is. There's my equation. Have I translated it to polar yet? No. All right, so let's translate it to polar. So that part's r squared. And you have learned that x is also known as r cosine theta. And now why did I set it equal to 0? It's classic positioning for the solving part. If you want to solve it, you want something times something equals 0. So then you could set this part equal to 0 and that part equal to 0. And so, once again, for the 35th time this year, when it was a hard problem, it came down to what? If you can factor it, it should. There's an r in both of them. And now you might feel like, well, how does that even help? I still have 2 r's. Well, because if you have it as a multiply problem and equaling 0, then this part has to equal 0, and this part has to equal 0. Oh, wait. R plus 4 cosine theta equals 0. Now this one's already solved. R equals 0. Now that's kind of a weird answer. I'll just say it this way, because that means it's a circle with a radius of 0. What does that mean? It doesn't exist. A circle with a radius of 0 is not anything. It's not even a point, is it? If it doesn't tell me an angle, we're going to consider that to be a circle with a radius of 0, which is like it doesn't even exist. This other one can be solved by getting the cosine to the other side, and now I got r equals negative 4 cosine theta. Why is that any better? Because I got r alone. R is equal to that. Yes?
I got the same answer, but I just subtracted 4 times r times cosine theta divided by r.
Okay.
R squared plus 4 times r.
Okay, so you squared some stuff and
Well, I multiplied by r, so I had r squared plus 4.
okay, we can multiply by r on both sides. Is that what you're saying?
Yeah.
Then we'll have like that.
Then I just subtracted the whole chunk of 4r cosine theta and divided by r.
Okay, but then basically, do you get you multiplied by r and then at the end you divided by r, and so wouldn't it end up coming out the same way? I mean, how about this? Didn't? Okay, it does, but it's kind of like, Mr. Server, I multiplied everything by 5 and then I divided everything by 5. You can do that, but it doesn't really help you to solve it. You know what I'm saying? You weren't wrong, you just took 2 extra steps you didn't have to do. Yes?
Like I didn't factor it, but I still got r equals negative 4 cosine theta, but I didn't get r equals 0.
Okay, but since r equals 0 is an extraneous answer because it's a circle with a radius of 0, I don't even want you to have that answer.
Okay.
Yes, sir.
So on the test, you won't want us to write r equals 0.
I would be torn on whether to mark it wrong or not. So just don't put it down, so I don't have to even decide. Okay? Because I know for some kids, if they get this far and the only thing they do wrong is leave r equals 0 on the test, I might be tempted to give it to them. But since you now know that I'm saying don't include it, because does it really make sense? A circle with a radius of 0? There's no circle and there's nothing there. So don't include that one. Any other questions? All right, let's move on to this guy. Find the intersection. Well, if you had normal rectangular ones, you just stick the one equation in the other. Well, same thing here. R equals 2 goes here. 2 equals 4 cosine theta. Divide by 4. 1/2 equals cosine theta. And we've done these a gajillion times by now. Oh, students, take calc. Where is cosine positive? Because it's positive 1/2, right? So where is cosine positive? Here and here. So these have to go. And then, am I doing inverse trig right now? No, I'm doing polar. It's not inverse trig. Okay, so I can have answers in both. There's this one, cosine ka adjacent over hypotenuse. The adjacent side is 1, hypotenuse side is 2, and that makes this root 3, and that makes this a pi over what? Pi over 3, also known as 60 degrees. And then this other triangle down here, that we know this is also pi over 3, but it's a whole bunch of pi over 3s all the way around the horn. Now, some people are going to ask, can I give the answer as a negative? You're not supposed to. If you can give the answer as a positive, you should give the answer as a positive. So it should be this one, pi over 3, and this one, a whole bunch of pi over 3s, 5 pi over 3. Now, some people will have left their answer that way, and depends on how the question is worded. If they ask you for the points where they intersect, do you get to get a point? I need an r and a theta. How many of you guys included the r equals 2 and said 2 comma and 2 comma? How many guys did that? Okay, that was good, but I wasn't clear in the directions, so don't consider it wrong. But do you get, if they ask you for with the points where they intersect, then you'd need to give a point which has an r and a theta. All right. Okay, moving on. This kind graph, I did after the fact tell you that you just needed 3, but on the test we'll be clear about how many we would want you to graph. All right, so if you're going to graph these, you need an r and a theta. And what's the r? You don't want to pick the r's. You want to pick the what's? The thetas. So what's a good theta? Now on this one I want to call on people. So dice of destiny, who should I call on? Row 2, last person. That's you, Mr. C. Give me a theta.
Pi over 3.
Pi over 3 is a good choice. I'm going to put it right there. And you need to walk me through this. How did you figure out that next part? Did you draw a triangle?
Yeah.
Which triangle? All right, so 30, 60, 90, 1, 2, root 3. Now what?
Well, the angle was 60.
Good, so
That is going to have half.
which is 1/2. That's 1/2. Excellent. So 3 times the 1/2. 3 times the 1/2 makes 3 halves, or 1.5. Raise your hand if you had that one right. Cool. Let's see, who else should I call on Dice of Destiny? Row 3, person 4. That's you, N. Try not to say the names on the video. What would you do for another one? You can pick any one you want. Yep. Pi over 2. You chose a quadrantal. That's here. So, how am I going to do cosine of pi over 2? Cosine is the x at this point. What is that point? 0, 1, which makes the x 0. So this is 0. Little blinking eraser is driving me insane. I'm going to make it stop by doing that. I think, there we go. Okay, so now I have 3 times 0. Did you have, did you have 0 comma pi over 2? Okay. Now, is there a dot there? Yes. Now, we just talked about this in the context of the other one, but since we have an angle and a 0, we're going to go at the angle pi over 2 and go distance of 0. We are going to put a dot in for that one on our polar graph. I shouldn't be graphing it on a rectangular. But here's our polar graph I'm going to start developing. I want you to just think this through. Do you get cosine can never be bigger than 1 normally? When you think of the cosine graph, it just goes up and down, right? Actually sine, but slide it over. Can't slide it over. The axis is actually there, but anyway, it just goes up and down, and 1's the highest it ever gets. So if cosine's biggest it can ever be is 1, then I times it by 3. 3 is the biggest this graph could ever be. Okay, so I'm going to make 3 circles. That's radius 1, that's radius 2, that's radius 3. So 3 is the biggest it could be. And now it is going to be 3 at what spot? Who figured out 3 comma something? Yes, ma'am. 3 comma 2 pi. And 0 is synonymous with 2 pi, right? 3 comma 0 degrees. 0 degrees and 2 pi degrees are the same thing. All right, so then let's graph these points. 2 pi and 0 are on the same spot, and I go out 3 and I put a dot there. That's out 1, 2, 3 spots right there. And then 0 pi over 2. Well, 0, anything can go right there. And lastly is 1.5, that's what this is, comma pi over 3. Pi over 3 is an angle of about 60 degrees. So if I shoot this out about 60 degrees, then I hit the 1.5 mark, that's about there. Do you get that those 3 dots are part of a circle that makes up cosine? All right. It's only 3 of the dots, but if you graphed more of them, and eventually, if you use a calculator, you could type it in and see that, oh, it's a circle. All right. Big picture, just want to tell you some stuff about these. R equals cosine. It's a circle that looks like this. R equals sine. That's a circle. It looks like this. Oops, missed it. Okay. What if I make it negative cosine? Do you get, I'm actually making my r's negative by doing that, because r was equal to this, and now I just made it negative. Just made all my r's negative. What does that do? That transports every point. It's reflected across the origin. And this is going to transport every point over to the other side, and we'll end up with the circle over there. Same thing with if I make this a negative sign, it's going to make all the r's negative, so all the points have to go to the opposite side, and so down here. All right, a couple more just for fun. Sine of 2 theta. That's the kind that ends up getting like a leaves with leaf petals kind of thing. And if you want to add more in there, like sine of 5 theta or 10 theta, you get more and more and more leaves. All right. Don't have too much time for that kind of stuff today, but just wanted to show you a few of the fun ones. The most fun one is the cardioid. That one, as long as these two numbers are the same, doesn't have to be 3s, could be 2s, could be 5s, then it makes that kind of a shape. It's kind of cool. All right, so polar can make all kinds of cool shapes, and if we had time right now, we'd be doing the polar lab, which does that, but I have decided that you've been working really hard to up to this point to stay caught up for this test, and I don't want to try to throw it in at the last second here. So I think we might do an explore polar day in class, but we're not going to write it up as a lab. We'll do not the whole day, we'll just take a few minutes, but today didn't seem like a good day because we don't have that much time. Okay, so any questions that have grown now since the beginning of the hour, like, I just don't get this kind. This would be a great chance to get those answered. Yes? Well, you have to find 4. Do you mean like the graph? Like this kind?
No, not that one, but I think it's related to further product.
Yeah, I got you. Okay. So let's say that I give you a point and it's right here, and I say, tell me 4 names for that. You want to start with a negative point? All right. So again, I like to think of these as this doesn't exist. -8 can't exist, but I can go to +8, comma, whatever, and then reflect. All right, so -8, comma, I don't know, 11 pi over 6. That's a place. Everybody, see if you can figure out where that spot is. You don't get there directly. You go to a real place, and then you reflect, and then you'll be there. Do you agree 11 pi over 6 is obviously involved here? And hopefully you know where that is. 11 pi over 6 is like that, where that's a 30-degree angle. And this 11 pi over 6 is technically all the way around to there. Okay? Then, this distance has to be the radius, which happens to be, in this case, 8. So this is not your point. Because that would be the point, +8, comma, 11 pi over 6. So to get to this point, I now have to take this point and make him the opposite of, which takes him and transports him over there. That spot has the name, well, it does have the name this, but it also has a positive name, a more normal name, where that's +8. And that's a whole bunch of pi over 6s. How many? 5 pi over 6. And then there's a bunch of names. This was one of them. Then I could say this another way and say it's 8 comma negative pi over 6. Do you get how I got that? And now if I want to transport it over here, I got to call it -8 comma negative pi over 6. What I just did there? I took this real point right here, 8 comma negative pi over 6. Do you get that that was a real point that's on the graph? And if I want to then move him over here, I have to say opposite of the radius. And that's why I named it this over here. So this is one of the other names for this point. I've got 3 of them so far. This one that I started with, and this one, and this one. Now there's one more. I got 2 negative r's and I got 1 positive r. That means there's another way to do it with a positive r. So +8 comma, what's another way to use a +8? Negative 7 pi over 6. Okay, so there's a little review of that stuff. All you can do is practice them. I know if it's like not making sense in your head, all I can do is I can do more problems with you if you want to. You can catch me after school. That is your last kind of chance to get help from me is after school today, because tomorrow is a Friday, and we don't have hours on Friday. Any other questions? You have a question? Yes.
Like the final answers,
Yep.
are they all going to be positive?
If you want 4 answers for this spot right here, then you'd need 2 with positive r's. That's these guys. Tweak that a bit to be 5. And you can have 2 with negatives, which would be these 2 points, except with a -8 on them. So I wrote them here and here. So I like to think of it this way. If I've got a point here, there's always the shadow point over here. And if you just name these, let's say I call this 3 comma pi over 6. Then I can give two names for that point, 3 comma pi over 6 and 3 comma, use a negative angle, negative 11 pi over 6. And I can give two names for this point. That's 3 comma positive angle, 7 pi over 6, and 3 comma a negative angle, negative 5 pi over 6. Then, if I was asked for 4 names for this point, I'd say these 2 points plus these 2 with negatives on them. You know what I mean? All right. Okay. Any last questions? I'm going to stop the video at this point. I think that's a good review. It does not cover everything, but it covers a lot. And your job tonight then is go do some old problems. There are keys posted and problems we skipped or problems we did, but you may have forgotten how to do because it was 5 days ago or whatever. So, and that's all I got for you for today.